It's me again, Miss Faust, back with another lesson of Algebra 2 notes. Today we're going to look at factoring. Factoring is something I hope that you did a lot of in Algebra 1. So we didn't used to do a whole day of it in Algebra 2, but we've decided that most people need a little bit of help with it, so it wouldn't hurt to do a little review. So we're going to look at how we factor in order to solve quadratic equations. We solved with square roots last time. You'll see these equations look a little bit different, so we use factoring instead to solve. So the big idea here is when we factor x squared plus bx plus c, we're trying to rewrite it as x plus or minus something and x plus or minus something. And those two somethings, so this and this, when we, I'm going to call them P and Q actually, it'll be easier to have letters in there. So P times Q always has to equal C, which is this value right up here. And P plus Q always has to equal B, which is this middle number. So hopefully you remember this a little bit from Algebra 1. When we're looking for the factors of something, we're looking for numbers that multiply to give us this number and add to give us this number. So let me just take a minute and show you just a couple examples of that. And once you've seen a couple examples of it, we will go on and look at how we use that to then solve quadratic equations. So for example, if we wanted to factor, let me call this example 1. Say we had x squared plus 12x plus 120. So we're trying to figure out when we factor that. So I'm trying to factor here. And factor means figure out two things that will multiply to 120 and add to 12. We're really undoing FOIL or the box method here. So if you think about this stuff, this is the stuff that would have gone on the side of the box method. And then this is what we get on the inside when we multiply everything out. Helpful for you, then think about it that way. If not, don't. So again, we're looking for two things that multiply to 120 and add to 12. If we had a number in front of the x, it wouldn't be 120 that we wanted to multiply to. It would be a different number. But for now, we're only going to look at ones that have just x squareds by themselves in front. So some of you are probably already thinking about those numbers that multiply to 120 and add to 12, and that is not right. I wrote the wrong problem. This should be a 22. There we go. Multiply to 120, add to 22. I don't want to start over. I make mistakes. You know that. You'll get used to it if you're not already. If you weren't already thinking and trying pairs of numbers in your head, what I like to do with these is I like to take the number they multiply to, which is 120, and start thinking about some pairs of numbers that multiply to 120. So 1 times 120, but 1 plus 120 isn't going to equal 22. 2 times 60, 2 times 60 also isn't going to equal 22. Because this has a 0 at the end, I like to think about dividing it by 10. I divide it by 10 and I get 12. Lo and behold, 10 plus 12 equals 22. So that means that those are my two factors in this case. So I'm going to write in x plus 10 and x plus 12. And again, those numbers come from here because they multiply to 120 and they add to 22. If we had negatives or if we were looking for a negative number here, we would consider negatives as well. But if everything's positive, they're going to be positive. And just to show you why that works, if we multiply this out real quick, x times x is x squared. X times 12 is 12x. 10 times x is 10x. 10 plus 12 is 22. And 10 times 12 is 120. So that's how we know that works. Like I said, we'll do a couple examples of this and then take that on to solving. So x squared minus 10x plus 25. So again, we're looking for two things there. This time we want them to multiply to 25. Remember, they multiply to the number at the end. And we want them to add to the number in the middle, which is negative 10 here. So again, I start thinking about factors of 25. And when I think about factors of 25, I think about 1 and 25. Well, 1 plus 25 is not going to equal negative 10. And wait, now I see I need it to equal a negative number. So let me try negative 1 and negative 25. Those still aren't going to work. Another pair I might think of for 25 is 5s, 5 times 5. Well, positive 5 times positive 5 works, but positive 5 plus positive 5 is not negative 10. So I'm going to go one step further to negative 5 and negative 5. Negative 5 plus negative 5 is negative 10. So that's my working values. And this is x minus 5 times x minus 5, or x minus 5 squared is how you'll usually see that one written. Either way is fine, but you'll probably see it written the second way. One more example. This one is x squared plus 2x minus 48. So again, working with positives and negatives a little bit. In this case, we want two things that multiply to negative 48 and add to positive 2. So you start thinking about those numbers. Think about them, maybe make a list. So out here, put a negative 48. Start listing pairs of numbers that multiply to that. I'm going to give you a second to think. And hopefully by now you came up with positive 8, and negative 6, or negative 6 and positive 8. The order doesn't matter. The important thing is that 6 is negative and the 8 is positive. So when we write it into our factors, we're going to write x plus 8 and x minus 6. So that's the factoring review. That's Algebra 1. Hopefully you remember a little bit of that, and the more you practice it, the more it will come back to you. So what we're going to look at next is how we can use that factoring idea to solve quadratic equations. Often using factoring to solve is a really quick way to find our answers to a quadratic. Way quicker than the quadratic formula, which we'll get to eventually. So when you are solving by factoring, there's a few steps that you have to do. Step 1 is to get your problem equal to 0. So on one side you need a 0. Step 2 is to factor, and that's always going to be the side not equal to 0, so you're going to factor the other side. Look back at the previous notes for clarification on that. Then you're going to set each factor equal to 0. And the reason for that is if you have a multiplication problem, and you know the product is 0, the only way that can happen is if one of the two pieces is 0. So finally you solve those equations. And I think this will start to come back to you as soon as you see a couple of examples. You can't always solve by factoring, so one thing just to keep in mind as we do this, we want to use this when we have x squared in the beginning, not when we have something times x squared. So if we have like 3x squared or negative 5x squared or something like that, factoring is not going to be the easiest way to solve first. So we're just looking for an x squared by itself in the beginning, then we're going to try and factor. We still won't always be able to factor, but we usually will. So example 1 of this, I'm going to start over the numbering since it's a new kind of problem. X squared plus 8x equals negative 7. Quadratic equation because we have a squared. We can't use square roots to solve this because we have an x and an x squared term in it. So we're not going to use what we did last time at all. What we're going to do instead is go through these steps. So in order to get it equal to 0, I'm going to add 7 on both sides. And what that does over here, the x squared can't combine with the 7. The 8x can't combine with the 7. So the 7 just hangs out by itself. So now I have an x squared, I have a bx, and I have a c. So in this case, I want to look for the two numbers. Now I'm going to get to that factoring step. I'm going to look for two numbers, and I'll just put a little arrow over here. two numbers that multiply to 7 and add to 8. And at first you're like, Miss Faust, there's no numbers that multiply to 7. Always messes people up. There actually are. There's exactly two pairs of numbers, whole numbers, integers, real integers, that multiply to 7. 1 and 7, or -1 and -7. So when I look at that, the one that add to 8 is that pair. So those are the ones I'm going to put in here. X plus 1 and x plus 7. I've factored it. Now I need to set each factor equal to 0. So kind of like the absolute value problems, I'm going to split this into 2. And I'm going to solve each of those. And some of you can look at that and immediately see the solutions. If you can do that, that's awesome. If not, this will get you there. Subtract 1 on both sides, subtract 7 on both sides. So our solutions are x equals -1 and x equals -7. Notice we don't get the same thing with a positive and negative like we did when we used square roots to solve. Okay. Example 2. I think I might do 3 examples of this. Let's do this one. N squared equals n plus 56. So the fact that it's an n doesn't change anything. I think you probably remember that, but sometimes it throws people for a loop at first. So the n doesn't change anything. The next thing to notice here is we need to move things to one side so we get a 0. My advice to you is always keep your squared term positive. It just makes your life easier later. So I'm going to move the n and move the 56. So what that will look like is n squared minus n minus 56 equals 0. Got kind of out of alignment there, but those will cancel and those will cancel, and we're just left with a 0. So we get to that point. Now we need to factor it. So we need to think about two things that multiply to -56 and add to -1. Well, if we think about -56, I know if I'm multiplying to a negative, I need a positive number and I need a negative number. I'm not going to try -1 and 56 or -56 and 1 because I know they're not going to add to anything near that. What I will do is try some other numbers. So like 56 I know can divide by 2. 2 and -28, or -2 and 28. And I actually have a calculator here. You can see I just went and I did 56 divided by 2, and I saw that it was 28. So I knew one of those then has to be negative, but neither of those add to -1. If you know your multiplication tables better than I do, you can probably do this more quickly, but I want to keep trying. So 56 divided by 3, uh-oh, that's not a whole number. 56 divided by 4, that one is. So 4 and -14, or -4 and 14. Again, I know one has to be negative to get that -56. Those don't add to -1. So I'll keep going. Doesn't divide by 5 because it doesn't end in a 5 or a 0. Doesn't divide by 6 because that's an icky decimal. 7 and -8, or -7, sorry, and 8. Right, so one of those pairs should get me there, and I look for a minute and I see, yes, it's 7 and -8. Sorry, I forgot to change colors that time. You'll forgive me. So 7 plus -8 is -1. So over here I write n plus 7 and n minus 8. Split it into two problems. N plus 7 equals 0, n minus 8 equals 0, minus 7 plus 8. So my solutions are -7 and +8. And again, the equations that I'm solving are the equations from my factored part. Some of you will start to see that the solutions are the opposites of those. So if you want to skip straight from here to here, by all means do so. Just make sure you're remembering to make those the opposites. Okay? I believe we will stop there. So, thank you very much for your attention, and we'll keep doing this in class next time I see you. Have a wonderful day. Goodbye, Mustangs. Woo!